All right, boys and girls, today's gonna be a quick day. Just day 2 of graphing rationals. I just did this second problem off your homework in class. So basically, it's the same idea as yesterday. We're focused on horizontal and vertical asymptotes, and let's talk about the roots. So for vertical asymptotes, we set the bottom equal to 0. So x equals 0, x plus 4 equals 0. So that means my vertical asymptotes are x equals 0, x equals -4, and x equals +3. For my horizontal asymptotes, we look and see, okay, well, if I multiply this times that, it's going to give me 2x squared. And then on the bottom, x times x times x, that gives me x cubed. And I know I got other stuff, but I'm just worried about the degrees, right? I'm just looking at the highest exponent. So the top is less than the bottom, so that means my horizontal asymptote is y equals 0. And the last thing for my roots, I set the top equal to 0. So 2x plus 3 equals 0, and x minus 4 equals 0. So that means my roots are going to be at 4 comma 0. That's my easy one. And then -3/2 comma 0. The reason why it's always comma 0, that's what a root is. It's where it crosses the x-axis when y is 0. So I got all this listed on here. I got my vertical asymptotes, I got my roots, and then I have my horizontal asymptotes. Now, horizontal asymptotes, graphs can cross those in the middle here, so that's what you're going to see. But out towards the ends, they don't cross them. It's kind of a weird concept. But anyway, you don't have to know why or anything like that. Just know that that can happen. So we're going to use the calculator to try and get that final shape. We figured out where the roots are and the asymptotes and all that. So we go into our calculator, and we go into our y equals. And be sure you do all your parentheses and all that stuff. So the equation's kind of long. But when we go to graph, this is the picture we should get. And it's kind of hard to guess so what's going on in here, but as you can see, this graph gets really close to the asymptote. This one actually crosses the root 1 and then comes back down close to the asymptote. And on the inside, it got some crazy stuff going on. You got asymptote here, asymptote here. The reason why we're using the calculator here to help us out is just because by hand, this is a lengthy process, and if you ever had to do something like this, you'd be able to use technology and the calculator to help you. Now, with that said, can we use the calculator all the time? My argument is no, because they don't tell us where the asymptotes are, right? It looks like it's at -4, could be at -4.5, could be at -3.9, so you can't really just depend on that. The roots, if they don't cross right at a whole number, you could be guessing the wrong number. I mean, this one kind of looks like it should be at -2, but we know it's -1.5. So just use the calculator to help us and just guide us on what the actual graph looks like. Alrighty, good luck. See you later.